So the IBM Software Sub-Capacity Licensing definition and scenario examples. There is a disclaimer that the presentation has been compiled at goodwill by Kisalu Consulting using IBM documentation. IBM has not endorsed this presentation, and we did not also seek any endorsement from IBM. Kisalu Consulting is not responsible for errors, omission, or misinterpretation, so you should contact your local IBM representative for any clarification. The introduction and background. The content will have introduction and background, defining the software subcapacity licensing, scenario examples, and then a conclusion. We've seen yesterday, what the presentation yesterday, that we have various organizations running IT infrastructure, including virtualization technologies, and that is for them to save cost. And any software, any IBM software running in such environments may attract huge savings, but also become a burden in case processes and rules are not followed up properly. And there is an agreement between IBM users, IBM customers, and IBM in terms of how the software can be purchased, used, and even maintained. And the agreement is called the International Passport Advantage Agreement, and the link is provided. We've seen yesterday. And also in the IPAA, there is a statement that says that for any IBM software used in any virtualization, then ILMT becomes compulsory. We've seen yesterday, and there is a simple rule which means that if you are licensed, you will be licensed at full capacity if you don't have ILMT and you're using the software in virtualized environment. There are a few exceptions which we've seen yesterday. And the ILMT is a free tool accepted by IBM, and also the IBM Big Fix inventory can be accepted, but it's not free. ILMT is freely available to customers, to IBM customers, at no cost, but you need to order so that you can benefit the support. Defining the software subcapacity licensing. How do we define our environments so that they can be acceptable for subcapacity licensing? As a background, we know that before the advent of multi-core processors, IBM used to license products linked to the server and the number of processors that are in the server. And there were no multi-core processors, which means that for one chip that was in the server, it was just one core. So it was a single core type of servers, and they were giving for a particular type of processor. There was a price that was linked in terms of the number of processors of chips that the machine had. So it was just a simple calculation. On the second bullet, we see that since 2005 and 2006, there were multi-core processors in the market, and IBM officially then announced the introduction of a new license metric measurement, which was called processor value unit, or PVU. Then they dumped the per processor licensing for many products in 2006. Thereby, from 2005 to 2006, we could see that on one chip they could put multiple cores, and then it was dual cores or even quad core and so on. Then the last bullet is that the PVU licensing model is based on cores that are on a particular chip. then the cost involved on multiple core is oriented in line with the computing power of the server and in line with the performance of the processes that you have on your machine. The higher the number of cores that you have, if it's a dual core, quad core, the more you will pay, because then the performance of the machine is higher. That's how now IBM aligned the licensing of software. To understand better, we have to define the sub-capacity licensing in terms of the physical environment and the multi-core or virtual environments that we may have in some of the environments. Here we have an example where to determine a physical environment, we have two socket server and each socket has 4 cores. So for this type of machine, we have a total of 2 times 2 sockets times 4 cores each. Then it makes it that we have a total of 8 cores for the machine. It's a physical environment. If we have to run IBM software on this environment, it is not a virtualized environment, so we will pay for the total of 8 cores. Now comes 2005, 2006, where the technology evolved. So we could see that there were environments whereby sockets were stitched with multiple cores. So we could have in one chip multiple cores, and within a server we can also have multiple sockets. This brought a problem whereby IBM changed the model, but more, they also came the advent of virtualized environments, whereby from one server machine you could use the available virtualization technologies and create different environments. So if we take the previous example of one server which had 8 cores, from there we can use the virtualized technology and create 3 machines and allocate each of the machines a number of cores. We may create 3 VMs and give to the first one 4 cores, the second one 3 cores, and the third one 2 cores. And all this runs on top of the server that had 8 cores. We can see that even the total of cores that we now have in a virtualized environment is even higher than the total cores on the physical machine. So there came a question on how do we now try to monitor how people are partitioning, creating new virtual servers, so that when it comes to IBM licensing, they will also pay as per the number of cores on which the machine runs, on which the software runs. That can bring a lot of savings to people, because if you have an 8-core machine and your need for running the software only requires 2 cores, then you can partition the machine and run your software on a lower core machine so that you pay less. So IBM allowed people to do that, and they made it conditional that you install ILMT, so that ILMT will be able to inform IBM on how many cores you have used over a certain period of time. The possibility here is that because now the software is is being licensed per core. It might be that during peak time where you have a need for increased power on the machine, you may also have the possibility of shifting 2 cores from this big machine, which is ideal, does not need so much power. At that time, you may shift them to a machine which had 2 cores, let's say at the end of the month, where you need increased processing power for this machine. So you can shift the 2 cores that side, and this machine now, which is running a particular IBM software, will be performing at higher levels, but still paying less money because it was registered with 2 cores. To resolve that, you need ILMT so that any changes that you make will be recorded and you will pay accordingly. That's why IBM made ILMT compulsory so that they can monitor how people are using their virtualized environment. Now, if we define the sub-capacity licensing, it is just a scheme which is based on charging the capacity of the partition or the VM machine, the virtualized machine, where the software license program is running, rather than license the full machine. So you can pay less if you want to benefit from sub-capacity licensing. The license is PVU based, and the program will allow you to pay less than the full process of the capacity, provided that your virtualization technology is eligible, and the list of all eligible technologies are on the IBM Passport Advantage website, and it is updated regularly. With this ability to increase or decrease your licensing need, you will therefore then pay for what you really need at a particular time. As long as you report, as long as it is recorded, you can even fluctuate your needs. It should be fine. But there is a problem when there is no tracking, no indication on how much you've been using when. So you'll be licensed, your customer will be licensed at full capacity unless there are steps to change the status to sub-capacity licensing. There are a few exceptions, but IBM will consider an organization at full capacity unless ILMT is implemented. It means that if there is an environment using virtualization and there is no ILMT implemented, the customer will use the sub-capacity right. And if the customer does not have the sub-capacity right, then the customer will pay the full capacity licensing fees. And with the full capacity licensing fees, it is all your active cores that will be charged. As an example, if we have a P-series machine which has 62 activated cores, and we only indicate one single core for the LPAR, where we install an IBM product like DB2, even if that machine is running at .2 CPU, it will be rounded at 1 core. So it means the DB2 will be using 1 core instead of the 62 core because it's running on the LPAR. So if you are not tracking that, for example, and on a P-series machine, P770, for example, if there was no way of tracking that, IBM would have charged with 62 cores instead of the 1. which makes it a big difference, which can go up to around $2.8 million. It is a lot of money. Then we have a few scenarios that we aligned so that we can share views on how this can be exploited in customer environments. There are many products and many scenarios that can exist, and based on what we explained above in terms of sub-capacity and the virtualized technologies, we can also have different type of cores on the machines, on the virtual machines. We have a few examples based on IBM MQ and WebSphere, just to illustrate some of the licensing ways that can happen in customer environment. On the scenario 1, it is a full capacity view, whereby we have a machine, a server. It's one server. It has 16 physical cores in total. We have 2 processors, Intel processors, each having 8 cores inside, and we installing MQ in the machine. Because it is full capacity, it will be that all the 16 cores will be licensed. The environment is not virtualized, so sub-capacity licensing does not apply. And in order to calculate the power of that machine, there is another table which IBM makes available to the customers. It's called the PView table, where each of the eligible technologies will be given a certain power. So your Intel, let's say Intel 3400 processor might not have the same PVU value as a Intel 3600, for example, if there is any. So you need to go check on that table what will be the PVU value for each core on that technology. Then for this example, which will be on full capacity, meaning we will license all 16 cores, we will need to multiply, we need to obtain the full value of the machine in terms of PVUs. So we'll multiply each cores times 70, which is the value that IBM gives that technology. Then we will have a total of our PVUs. Then we will have the cost per PVU for that particular software to give us the total license cost that we will need to pay. So it will be 16 cores times 70 PVU per core. And if we take an example of $50 per PVU for that particular software, it means that using MQ on this machine will require that the customer pays $56,000. The second scenario is based on sub-capacity, where we have 2 virtual machines. So the same server 1 that we had before, the server 1 with 2 processors, Intel Xeon processors, we also have a total of 16 cores, with each processor having 8 cores, so it's 16 in total. Then we divide it in 2 machines, which is each VM will be assigned 8 virtual cores. Then we have MQ installed on the first machine, and we have MQ installed on both machines, machine 1 and 2, and we have WebSphere installed on the first machine. So we will also go check on the PView tables. So we need to go there, the model of that processor and how much each PVU is valued on that table. Then we will extract that so that it will help us to calculate how much we will need to pay for this type of server. This table now shows that in this situation where we have MQ on both machines and WebSphere on one machine, if we had a full capacity scenario, how much was the company or the customer going to pay? So in full capacity scenario, both MQ and WebSphere would have had access to 16 cores because there is no division, there is no partition. And if we go to the PVU table and extract 70 PVU per core, it means that at a price of $50, each of the product would have paid 16 times 70 and times $50 per core. It will be around 56,000 US. So here, because each product will pay the same, then we make it times 2, which will be $112,000. That is in full capacity scenario. But here we have a sub-capacity scenario where we have 2 VMs. So MQ will have access to 8 cores plus 8 cores, which will be 16. And WebSphere only has access to 8 cores. So our calculation for the 2 software in a situation where there is virtualization will be different. So MQ will pay 16 times 70 and $50 per PVU, which will make it 56,000 USD. And WebSphere will pay 8 cores, that it has access to 8 cores times the 74 PVU at $50 per PVU. That will make it $28,000 USD. So there is a saving of around $28,000 in the scenario where we have our virtualized environment compared to the full capacity. So that is a good saving if somebody will have to save around 280,000 rand. We have a third scenario where we have a server with 2 processors and it has 16 cores in total. But because the technology allows, as you've seen before, to allocate a number of virtual cores, it is possible that we can create 2 VMs and give 12 virtual cores on the first machine and 10 to the second machine. It makes it 22 cores, which is even higher than the 16 cores that we have on the physical machine. Now, in the case where we have virtualized technology, within the IBM license metric tool, there is a need to create what is called VM managers. It must be defined. So if you don't define what is it that the VM manager does, it goes into the machine and extract the architecture of your physical server and the links that it has with the virtual servers. So it extracts all the information about the technology that is underlying the whole environment. Then that information is also now linked to your PVU tables so that you can extract the correct PVUs for the type of processors that you will have. So here we have 12 virtual cores and there we have 10. So it makes it 22 cores with which is higher than the 16 physical machine. If you do not have a VM manager defined, so license metric tool will not have access to the information of your sockets and physical cores of the VMs that are deployed. It will only have access to your cores, to the information of your cores. And then if you go into the PVU table, you might see that these cores will be allocated a very high PVU value. That can become very detrimental. So the PVU, the core, depends on the socket of the host, and if ILMT cannot access that information, it may assign it a very high value, which will make the cost very high. So for example, in this case, if your VM manager was defined, it could read your table information to relate to 70 PVUs per core. If that information is not there, the PVU table may then give you a value of 120 PVUs per core, which is very high. Now, in this scenario, we will have, if the VM manager is not defined, the cost will now show in a different way. So we will see here, if we have the VM manager defined, the VM manager is defined on your full capacity, as we've seen before for that machine, it only has 16 cores and 70 PVU per core. At $50, we should have been paying $56,000 on a full capacity scenario. Now, on a sub-capacity scenario, we have a total of 22 cores. If you remember, there was 12 and 10 core virtual cores, which makes it 22. But the rule is that IBM cannot charge you more than the actual physical cores that are on the machine. So it will be capped at 16, although you have 22 virtual cores that you created. So if your virtual manager is defined, then it will pick up that information for your PVUs correctly. Then you will only pay 16 cores and your PVU at 70 PVU per core. Then you will pay, in terms of the sub capacity for your IBM MQ, $56,000 US. Now, if your VM manager is not defined, you will have your 16 core capped to your 22 cores capped to 16, but the PVU table might show you the highest PVU value for that particular technology, which may be 120, for example. Then you will get to pay your 16 cores times now the higher value of the PVU, 120. And if we take a $50 per PVU, then your cost is higher. Although you are on virtualized environment, because you don't have the VM manager, you end up paying higher than if you define your VM manager. We have the fourth scenario that we wanted to share, which is about your Docker containers. A Docker is a platform that allows for automating the deployment of applications inside containers. So if the conditions are valid, your ILMT from 9.2.10 can discover your software, that your IBM software installed into your Docker containers, and measure the usage for your metric utilization, license metric utilization. Docker is not a sub-capacity eligible virtualization, so it's not recognized as a virtualization technology like we've seen for other technologies, but can be used combined with eligible sub-capacity virtualization technologies so that you can measure your licensing for the product, the IBM product. As an example, here we have example 1. We have a Docker which is deployed on the physical server, and in this situation where it is deployed on the physical server, the PVU and RVU utilization is measured compared to your host computer. What does it mean? You can see from this example here that we have 3 containers. Let me start from the host. We have a host physical machine which has 4 processors, and each processor has 6 cores, which makes it a total of 24 cores. Now we have MQ installed on container 1 and 2, and we have license metric tool that should measure how much usage is for MQ on this type of machine. Here there is no virtualization. It's a full capacity type of scenario. We have the BigFix client installed on the machine, and the Docker technology comes with a Docker engine that manages the container. So in this case, the MQ that is installed on these containers has access to the full 24 cores that the host presents. And now, if you have this type of scenario, we should go to the PVU table, get the processor model, and if the processor model assigned 100 PVUs per core for this type of machine, it means that we will have a total of 2,400 PVUs that will need to be licensed. Let's say we install again another container, a third container with MQ, and we want to know how much we should license. Because the 3 containers are running on the same machine and they only have access to 24 cores, it means that we will still pay 2,400. So the total, no matter how many of the number of containers that you put there, if they only have access to 24 cores, we will still pay the same. Then we have a second example whereby it is the same host, 4 processors, 24 cores in total, but now this scenario uses virtual machines, so it's virtualized. Now in this situation, we will have BigFix client. If you look at the previous scenario, our BigFix client is on the host, but in this scenario where it is virtualized, the BigFix client is sitting on the virtual machine. So there is a clear separation there. We have a host which has 24 cores, and they created 2 machines, virtual machine 1, virtual machine 2, but each of them only has 8 cores. So on each virtual machine, they also install a Docker engine which will control the containers. Because these 2 machines are completely separated and independent, the measurement will now be based on how much the software has access to the number of cores. So in this scenario, although we also have a physical server which has 4 processors, each of them 6 cores, and a total of 24 cores, but each machine only has 8 cores. So then we have MQ installed in one container, first machine, and one container we have one MQ, and in the other second machine we have 2 containers. Here we have one container with MQ on the virtual machine 1. On virtual machine 2 we have 2 containers having MQ. So in this case we will have a total of 8 cores there plus 8 cores instead of 24, which makes it that our MQ total access in terms of PVUs, in terms of cores, it will only be 8 cores, not 24 like before. And because the PVU table shows that we have 100 PVUs value per core, then our second scenario inside the Docker will be charged 16 cores total times your 100 per PVU, which will make it 1,600 PVUs to be licensed. So if the Docker engine was installed directly on the physical server, we would have paid 2,400 PVUs like in the previous situation. In conclusion, we note that IBM Sub-Capacity Licensing must be understood and applied correctly under conditions that IBM recommends. And ILMT, again, is a free tool that can save IBM customers millions, but can also become a burden in case it is not used according to the rules. And IBM clients must understand sub-capacity rules as they apply to licensing, to sub-capacity and compliance, so that they can benefit reduced software licensing fees. And there are many scenarios that exist for the thousands of IBM software that are available, and there are also hundreds of licensing schemes that are aligned for each of the products. So it's advisable to obtain the required knowledge and avoid unnecessary conflicts from customers, unnecessary misunderstanding, and non-compliance fees and non-compliance fines, which are not nice. It's not a nice situation to be in. If there are any questions, you can send to training@sun.com. Please, if you have questions now, you are welcome to either send them on the chat or you can use your microphone at the moment. Thank you for coming through, and we really appreciate your time. We will send you the recording and the presentation as we did, so by tomorrow morning you should have them on your email. Okay, thanks a lot. See you next time. Thank you.